Mercury. Mercury is the closest planet to the Sun, but that doesn't mean it's scorching all the time. At night, the temperature can plunge to an icy negative 180 degrees Celsius, while during the day, they can soar to a blistering 430 degrees Celsius. This massive temperature swing happens because Mercury lacks a proper atmosphere to regulate heat. Instead, it has only a very thin exosphere that can't trap warmth. Weather wouldn't really be a concern on Mercury, but survival would still be nearly impossible. The biggest threats are intense solar radiation and the complete lack of breathable air. Mercury receives almost 7 times more solar irradiance than Earth. As the smallest planet in the solar system, Mercury is also covered in craters, cliffs, and rough terrain, which makes landing extremely dangerous. With almost no air resistance, slowing down a spacecraft would be very difficult, increasing the risk of a high-speed crash. Landing during the daytime is completely unrealistic. Modern NASA spacesuits can only withstand temperatures up to 121 degrees Celsius, nowhere near Mercury's daytime heat. Mercury's slow rotation also means one day lasts about half a year. Nighttime isn't much better either, since temperatures drop far below the suit's lower limit of negative 157 degrees Celsius, meaning you'd freeze. The only semi-viable option would be landing in the Terminator zone, the narrow region between day and night where temperatures are more moderate. Though even there, conditions can change rapidly and remain extremely risky. And this is just one out of many ways you can die on different planets, and as the video goes on, they will get more brutal. Venus. Venus is the closest planet to Earth, coming within about 40 million kilometers, which would make the journey relatively short, roughly 4 months. Its size and gravity are also very similar to Earth's, so those wouldn't be major issues. The real problems start as soon as you approach the planet. Those thick yellow clouds surrounding Venus may look beautiful, but they're made of sulfuric acid, a highly corrosive substance that would destroy your lungs in seconds. Even assuming you had an advanced spacesuit capable of filtering it out, conditions would quickly worsen. As you descend, visibility would drop dramatically because Venus's atmosphere is incredibly dense and composed mostly of carbon dioxide. Then there's the heat, an unbearable 450 degrees Celsius at the surface. On top of that, only about 10% of sunlight actually reaches the ground, making the surface surprisingly dark. Despite Venus having nearly Earth-like gravity, movement would feel incredibly difficult, because the thick air would feel more like wading through a heavy liquid. Even with a reinforced pressurized suit, survival would only last moments. Surface pressure on Venus is around 92 bars, compared to Earth's 1 bar, which would eventually crush your suit. And once that happened, the sulfuric acid atmosphere would finish the job. Mars. Mars is the second closest planet to Earth and is often considered the most habitable planet in the solar system. Daytime temperatures can reach a relatively mild 20 degrees Celsius, especially near the equator. However, conditions vary greatly, and temperatures can drop to around negative 130 degrees Celsius at night or near the poles. Like Mercury, Mars has a very thin atmosphere, made mostly of carbon dioxide with only trace amounts of oxygen, far from breathable. This thin atmosphere leads to low surface pressure and high exposure to radiation. Average radiation levels on Mars range from 24 to 30 RADS, which is about 40 to 50 times higher than on Earth. Mars is also infamous for its massive dust storms. These storms can be extremely violent, with wind speeds reaching 100 kilometers per hour, and can sometimes engulf the entire planet. Because of all this, any attempt to live on Mars would require a fully sealed, well-insulated, and self-sustaining life support system. Jupiter. Jupiter is the largest planet in the solar system and one of the most difficult places to land. Its extreme radiation alone makes it deadly. At distances of 300,000 kilometers, the radiation would already begin penetrating a standard spacesuit. But for the sake of imagination, let's assume you have a hypothetical suit that blocks it completely. Jupiter's gravity is 2.4 times stronger than Earth's, so you'd fall incredibly fast once you entered the atmosphere. The upper layers are filled with white clouds of frozen ammonia crystals, with temperatures around minus 150 degrees Celsius. Winds here are ferocious, reaching speeds of up to 482 kilometers per hour. If you managed to descend about 150 kilometers, you'd reach the deepest point ever explored. Exactly how far NASA's Galileo probe made it in 1995. Beyond this, conditions rapidly worsen. Light fades, and both temperature and pressure skyrocket. Near Jupiter's center, pressure is estimated to be 100 million times greater than Earth's atmospheric pressure. After hours of falling, you'd reach inner layers containing a supercritical fluid, a strange state of matter that's neither liquid nor gas. Going deeper still, you'd encounter metallic hydrogen, an incredibly dense liquid that would trap you. And if you somehow made it past that, you'd reach Jupiter's core, possibly solid, possibly not, with temperatures around 24,000 degrees Celsius, roughly 4.5 times hotter than the Sun's surface. Saturn. Saturn is the second largest planet in the solar system and is mostly made of hydrogen and helium. Your first challenge would be avoiding its 146 moons. Once past those, you'd need to navigate Saturn's iconic rings made of debris from shattered moons, ice chunks, comets, and asteroids. Assuming you survive that, you'd witness stunning red and purple auroras caused by energized hydrogen in the atmosphere, near Saturn's equator. But this beauty comes with brutal winds, blasting at speeds of around 1,800 kilometers per hour, making stable descent nearly impossible. Trying the North Pole wouldn't help either, as it's home to a massive storm large enough to fit 2 Earths inside it. The upper atmosphere contains ammonia clouds and temperatures as low as negative 250 degrees Celsius. As you fall deeper, temperatures rise, eventually reaching 0 degrees Celsius, but pressure quickly becomes the bigger problem, reaching levels comparable to the deepest ocean trenches on Earth. Deeper still, the gases turn into liquid. At Saturn's center lies a molten rocky core about 10 times the size of Earth, with temperatures around 11,700 degrees Celsius, more than twice as hot as the Sun's surface, and pressures roughly 1,000 times greater than Earth's. Uranus. This is where distances become extreme. Uranus is one of the 2 ice giants and is the only planet that rotates on its side. A day on Uranus lasts just 17 Earth hours. Being an ice giant doesn't mean it's frozen solid. It means it contains heavier elements like water, ammonia, and methane. After avoiding its rings, you'd enter an atmosphere filled with toxic gases, where temperatures plunge below negative 220 degrees Celsius, making Uranus the coldest planet in the solar system. Descending further, the atmosphere becomes denser, and you'd be bombarded by ice pellets. Eventually, you'd reach something incredible: diamond rain, formed under immense pressure and driven by winds reaching 900 kilometers per hour. Unfortunately, the pressure here is about 100 times Earth's, which would ultimately crush you. Neptune. Neptune is the second ice giant and is very similar to Uranus. It's the farthest planet from the Sun, about 30 times farther than Earth, making it extremely dark. Its outer layers are bitterly cold, while its inner layers are intensely hot due to pressure and heat from the core. Neptune's core reaches temperatures of around 7,000 degrees Celsius, hotter than the Sun's surface. Like Uranus, it experiences diamond rain caused by methane breaking apart under extreme pressure. Neptune also holds the record for the strongest winds in the solar system, many reaching supersonic speeds. In many ways, Neptune is essentially Uranus's twin, just even more extreme. If you enjoyed this video, make sure to like, subscribe, and comment what subject I should go over next.